What's up, YouTube? Welcome to this next episode on So You Think You Know C#. This talk would actually been a Let's Talk video where the topic or title would have been Let's Talk LINQ. No, thank you. But I thought the better of it because this is more than just a talk. I'm going to have to show you the code that is produced with LINQ when you use LINQ so you understand some of the issues or problems I have with LINQ. And of course, we have benchmarks so we can prove our theories and we can prove to make sure that certain things are slower or faster in LINQ. Now, the example I have is a very simple example, which is intentional because if I make it too complicated, then people don't quite understand the problems. I've just taken a simple where LINQ, the where clause, and show you different styles in which you can accomplish the intended result, and then show you the benchmarks because it's sort of counterintuitive for the most part. At least it is to me. So in today's video, we're going to be going through a whole lot of things and a lot of C# code, a lot of explanation of IL, and of course the C# code itself. And we'll conclude with the net result of my recommendation. So for those of you who are impatient and kind of just want to know the TLDR version of it, this is what it is. Use LINQ wisely. I love LINQ. I love the concept of LINQ. I love the way it has been implemented in the C# language and the fact that there are other languages that are trying to mimic and copy this feature that we have and have had in C# for many, many years now, since C# 3 or 3.5, something like that. My issue with LINQ is it's almost like the benefits or what some might call the virtues of LINQ are actually my issues. The succinct nature of LINQ is beautiful, right? You can do a lot by saying a little, if you will, right? You just say where and it just sort of figures that out. But that same succinctness, I feel, is the problem in two ways. One is it's simple in terms of the way you write your code, but you don't understand. It's deceiving in that you don't understand what it takes to make that code really simple and the cost you're going to be paying for that simplicity. So a lot of the so-called cool features of C# I find are itself the demerits of C#. That's not to say you shouldn't use it. I said you should use LINQ wisely, which means understand what's going on under the hood and see if that's truly what you intended to happen in terms of the implementation. Now, of course, you're going to be concerned with LINQ or not to LINQ in performance critical scenarios or situations. So it's not like through the entire application, but maybe in a certain portion of the application where that's performance critical, you might decide not to use LINQ at all and resort to like a for or for each. Actually, you should be resorting to a for loop because fors are faster than for each and which is faster than LINQ. But that's to do with performance critical code, not your entire system. So if you're within the business system part of your, the business rules and things of that nature, that's not performance critical, then of course use LINQ, but keep it simple. Don't complicate LINQ. It's like an SQL statement. Don't make that SQL statement complicated. There are simpler ways to get certain things done, and don't be clever. Right? Because clever code is never a good idea. I mean, I used to write a lot of clever code, and I'm speaking from experience, where I kind of confused myself by writing clever code, and then 3 months later I go back to it and I don't understand what the heck I just wrote. Of course, it took me days to come to that clever code piece, and then 3 weeks later I can't understand what I wrote. So you shouldn't be writing clever code. Write simple code. Keep it simple. Now, of course, simple is not easy. Simple has various degrees for different people. Simple just means different things. I'm saying this is what you should be doing. At any point in time, you're writing some code that has the potential of either improving performance or causing you a performance problem. And so you want to, of course, test out that assumption to make sure that it is or is not slow or fast, whatever the case is. I always start with a baseline. The baseline is the simplest code possible. I'm not concerned with, am I using this feature of C#? Am I doing that? What do people say about the code they see? It doesn't matter. It's the baseline. It's the simplest form of code you would write to get that baseline. And if the baseline matches your needs, then you're good. There's nothing to do. If the baseline doesn't match your needs, then maybe you need to look elsewhere. You need to figure out what else can you do to improve the performance. For the most part, people start with, I'm going to make this really complicated, beautiful, elegant code. And then there's like, they just assume because they spend so much time behind it, that it must be good. Or in some cases, you write LINQ because, it's not a crime to write LINQ, right? So you write LINQ and say, well, it's just a LINQ statement, how bad can it be? I'm saying the baseline needs to be simpler or simple. Now, because simple will be various degrees for different people in different scenarios as well. So I'm going to, the code I'm going to show you here has a story, if you will. It was a progressive build up starting from the original code that was part of a code review. And then I presented that code to various people within my team to see if they could improve on it. And they each came back with their own version of what they thought was improving the code or not. So the story is sort of this progression of different ways to get to the same end, and then finding out that neither of them is actually making any improvement, or in some cases making it a whole lot worse. Yet the code looks elegant, it looks really simple, and you think to yourself, this just has to be better, right? And the beauty of these kinds of topics is that what appears to be is very infrequently what it really is. And that's sort of the underlying theme of this video with LINQ, because LINQ is one of those things. It seems very simple, but it gets really complicated, and you can't tell by looking at the code that you wrote to what that code ends up being when it gets compiled. And where are you paying the penalty? Why are you paying the penalty? And where are you paying the penalty? All right. Okay. So that's my let's talk part of the topic. Now we are starting with C# part, where you're going to see code and IL and benchmarks. So without further ado, let's take a look at some code. So here's the benchmark application. It's a very, very simple application. I've got a concept of a customer that's got a first name and a last name. And then I've got collections of customers, which are just different collections: verified customer names, certified customer names, and customer names, list of customer names, right? These are just simple hash set. And notice that they're in all caps here. I also have a string case insensitive comparer that I've defined, where there's a new instance already created, and I will reuse the same instance over and over. So we're not paying the penalty for creating the new instances necessarily, but we are going to be using this as part of one of the benchmarks that uses this. I then have a collection of customers. This is an array of customers here. And that's the new set of customers, except notice that the first names are in a different case intentionally. So we are trying to match. We're trying to find all customers in our list of customers that are in any one of these lists. That's the basic idea. The theme of the problem here is we have a set of customers, and we have to find the fastest way to determine if the set of customers is in any one of these lists or hash sets of customers identified by the first name. Now, the baseline is the original code that I saw during the code review. So you look at this baseline, and I'm going to ask you to take a look at it, and just for your own exercise, mental exercise perspective, take a look at what it is that you think is wrong here and where you could potentially fix it. And then I'll give you like a few seconds. If you need more time, please pause the video. I'm now moving on. The first thing I notice is that the first name is being too uppercased multiple times. So that seems to be like a waste, because the two upper is creating a new string. So each time you do a two upper, you're creating a new string, except this is not going to change here, the first name. So why do it multiple times? I left the to list in here, even though that's the first thing I'll look at. When you say to list, I'm going to question you right away. Why do you need a list? Like, are you planning to modify this? Are you planning to just iterate over this? Like, what's the real deal here? So that's what, but I've left it in here because that was a need here, and I'm returning a list intentionally. So all the benchmark methods return a list. All right. So now that's the original, the baseline, right? So the first thing I came up with was the let. I said, okay, well, if we have to use LINQ, then mind you, by the way, my gut reaction or my sort of the initial solution is to just use the for loop, because I'm sort of that opinion. If I'm questioning something, or if I'm doubting something about performance, I'm going to say, okay, what would be my baseline? I would resort to, in this case, a for loop, right? I'll say, okay, I'm going to write a for loop, and that's my baseline. What does that perform like? What does this perform like? And then I might make adjustments, right? So if it's close enough to the baseline, then I'm saying, okay, well, and the baseline is good enough, I'm going to say, well, then leave it be, right? If the baseline seems to be quite a bit faster, then I'm going to say, okay, what can I do to improve it without kind of breaking the original, if you will, too much, right? Not rewriting the entire thing. So of course, because it was written using LINQ, I'm saying, okay, how else could I write that statement in LINQ, where in this case, we're not using that to upper so many times, multiple times, right? So, but I have a baseline, and then I've used that baseline to see if I'm too far off the baseline, then what can I do to get closer to the baseline? All right. So what I came up with was this over here. I said, okay, well, I know in LINQ you can define a variable. So I'm going to set that variable to the uppercase version of the first name. And then I'll use that variable multiple times so that I'm not having to do a to upper each time. And I said, oh man, this should just definitely be way better than that, because I'm not going to be paying the price of doing the to upper and the string allocations multiple times. It's just one new string allocation, and it's going to be used to do the same test. So both of these are actually doing the same thing. Right? They're doing the same contains multiple times. This one just happens to be doing it with a single to uppercase and then using the same variable over and over. Right? So both of these should be comparable. So let's look at the benchmark results for these two methods, the baseline here, and then the one that has the let. So it says using query expression let and one to upper. So if I look at that's the baseline, this one here, and that's 527.6 nanoseconds. It's got so many allocations, so many bytes allocated, and so many Gen 0 collections. All right. If you then look at this one that we want to compare against, it is actually slower. So, because I had the baseline, which is I'm not discussing at this point. I don't think I even have it in this code. Probably one thing we should do while I do this video. The baseline is faster than the let. And I'm thinking, okay, that doesn't make sense. And that's the thing with LINQ, right? You cannot tell by looking at the LINQ query that you write that it's going to cost you. Or where is the cost? Why is there a cost, right? Why is one single let statement with one single to upper more costly than the original that was creating 3 allocations per iteration of an uppercased string? It just doesn't make sense, right? So you have to kind of dig deeper. That's the problem with LINQ, is what you see on the surface is not what you get. What you see is not what you get. And it's not what you get by a long shot. So you're starting to pay costs for things you could never have imagined. I mean, if I had not done a benchmark here, I would have said, well, there's only one uppercase here. The problem I'm seeing with this method is that there are 3 uppercases here. So it's this new one, the one that I got with the let statement here, is guaranteed to be fast. I mean, there's just no two ways about that. So why is it slower? That's the kind of thing I wanted to look at and understand how to look at, where to look at, what to look at. All right. So that's sort of the gist of this video. So if I look at the IL, let's take a look at the IL for these methods. Okay, so we have this one. That's the, what's the name of the baseline? Let me just verify the baseline method's name. It is using multiple to upper. All right. There it is, sorry. Okay, so that's the IL. So for now, we're not going to dig deeper into the IL. I'm just going to show you this IL as compared to this one, next one here. Look at the amount of code difference between this and this. Now, it's not always the case that more code means slower performance, but if you look at some of this code here, there's just a lot of instances of classes, right? And in some cases, you can see here, there are delegates. That's a func, another func, another func. And of course, there's anonymous types as well. Here, instances of anonymous types. This code is way more complicated than the original code that simply did that, right, with one delegate, which was the where clause itself, right? And in fact, that's what I'm looking at. I'm looking at this new obj instance That's a clue to new things being created. In fact, if I show this in C#, so that's the sort of the C# version. And then this is the multiple two-upper here. This is not good. So one of the things you have to be careful of or mindful of when you're working with IL and like IL Spy, when they convert it back to C#, you might, for the most part, depending on what you're trying to do, for the most part, you want them to convert it back to a earlier version of C#, like C#2 or typically, not the latest version. Because as new language features appear, the code will go back to that using the language feature, which hides some of the C# lowering aspects, right? I'm going to go back to 2.0 here. Yeah, so you can see that's a delegate, but it's simple, right? Even this is not that complicated. It's not doing anything more than you would expect. Whereas this code here, look at that. That's crazy. That is, I can hardly read this code, but it looks like, yeah, it's nested one delegate inside another delegate inside another delegate, each one returning anonymous types. Plus there are 3 new delegate instances. That's why this code is slow. Delegates are an indirection. It's like an interface or a virtual method. Just as an aside, maybe it's another. So you think, C#. Between delegates, virtual methods, and delegates, virtual methods, non-virtual methods, or interface methods. So delegates, virtual methods, interface methods, or classes that implement interfaces, non-virtual methods, and static methods. What is the order from fastest to slowest in terms of performance? I'll list it out again, and I'll give you hopefully if I remember, I'll give you the answer at the end of this thing. Virtual methods, interface methods, I'm just going to call it interface methods. These are classes that implement interfaces. Delegates, non-virtual methods, and static methods. Give me the order in increasing order, as in increasing, going slower, fastest to slowest. Right? And tell me what you think it is. Put it in the comments below. By the end of this video, I'll hopefully remember to give you that answer. But that's delegates here, so that's not going to be anything fast. And you're calling one delegate from another, that's 3 delegates. And that's why there's this performance difference between this, which was my attempt at trying to simplify it, and the original code, which was this. Right, so 527.6 and 655. I'm saying, okay, well, right away when it became slower, I'm thinking, what the heck is going on, right? What is so complicated about the let statement? It turns out that the implementation is what you just saw. So then I had colleagues of mine who gave some other implementations, for example, this method here. So, well, instead of doing the way it's done right now, let's use an equality comparer because we need to have it case insensitive. And rather than doing a 2-upper, maybe making it case insensitive will make it faster. So that's the gist of this thing. So let's look at that, the get using multiple equality comparers. So get using, that's the second one here. Whoa, look at that. That's even slower. Do you see how counterproductive this is getting? We're thinking we're improving on the original LINQ statement. Seeing the problem with the original LINQ statement was multiple 2-uppers. You're saying, okay, well, like that's obviously going to kill you. That's allocating 3 strings for every item in the collection. If you had 1 million items in the collection, you're just 3 times. So 3 million new string objects, that's going to kill you. Because I'm not doing that in the test. Maybe I should have had large collections to, sort of prove a point there. But every attempt at trying to improve on it so far has failed, right? So it's not getting any faster than the original. So let's go back to the next one then. So the next one was do this. Instead of having multiple 2-uppers, how about we only had 1 collection and do 1 2-upper? So you're still, twice, well, 2 less than the original, right? Instead of the 3 times, you're doing this only once. So let's sort of concatenate, if you will, the 3 hash tables, hash sets into one. and then do this test. Of course, just keep in mind all of these are getting modified, right? Which is not a good idea, but this is just more like an experiment now. So the 3 hash tests have been combined into one, and then you do the 2 upper just one time. And that is this one called using merge sets and single. So using merge sets and single, that's the third one here. I mean, I had a blast with this. I guess the original, the hunting for the better implementation part, because that was the more you tried, the worse it got. Right? And maybe you guys should take that same code, try your own hand at some of these things, do your own benchmarking, compare it with some of the code that I have here, because this is a blast of a exercise. And if the only way to gain experience is to have the experience. You can't learn from what I'm saying. You can understand from what I'm saying. But for you to actually learn it, for it to be sort of embedded in your brain, you have to have done it. Right? That's how I learn, and I think a lot of us learn like that. Our experiences are our experiences, and there's nothing that trumps experience. I don't care where you come from. I don't care how many years you spent doing whatever. If the quality of experience and the amount of experience is not good enough, it doesn't matter. But on the other hand, if somebody has huge amounts of experience, good quality experience, it doesn't matter what your educational background is, whether you got a degree or not, it makes zero difference. Experience trumps everything. All right. So then the next implementation here. So we didn't do well on this merging of the sets. Let's look at this one. We said, okay, let's use the concat method. So we tried the same attempt. So instead of doing the union, we said, let's do concat and see if that made any difference. And the result of that with the concat was, well, it's as bad, or actually the worst. So far, all attempts at making things better has made it worse. Right? So in fact, if you look at this graph here, this was the original, then this is the next attempt, and so on. So of course, this was the second attempt, but it should have been over here. They're literally going in that angle. Like the original was actually quite a bit better, and as we're trying more and more variations to the theme, it's getting worse so far. All right, so that's our track record. Okay, then we say, well, we did the let part, so I'll skip that for now. Then we came here and said, okay, how about we do a where? So delegates, this is the method implementation, if you will. And we define a local variable here with the 2 upper ones, and we use it this way. Instead of using the let, let's do it like this, sort of by hand, if you will, right? Instead of relying on LINQ to do something correct, we're doing it like this ourselves. So this becomes the entire delegate implementation. And so there's a local variable here in this thing here. So let's look at that. That's the get using local variable assignment. So get using local, this one here. So now this suddenly, which is this one, suddenly made it faster than that. So this is the first attempt so far, starting from this, the original. Everything else has been slower than the original. This is the first time now this has become faster. So the local variable using a implementation of the delegate rather than leaving it to LINQ to do its thing with the let is way faster. So in some ways, we're on the right track. Like that 2 upper is the problem with the original, right? So the only problem we could really see with the original was that, of course, there's a where clause, and so there's a delegate, but it was the 2 upper being used multiple times. And so this implementation said, okay, this is the cleanest way to get rid of the multiple 2 uppers, retaining the original kind of theme of the implementation, right, with the where clause. All right, and I said, okay, well, let me also just add for good measure a method that does this without LINQ. So this is a standard implementation. It's got a for each here, and this for each is normal implementation. Of course, then the 2 upper here, we are, I guess we're not worrying about. I'm not trying to be consistent with the answer. I was just saying, you know what, I'm just going to use the contains without trying to do case sensitive or case sensitive compare just to get a number. It doesn't really matter how many return items are here in this collection. And then in the next one, sorry, this one is upward. Right? This my mistake. This is upward. Again, it's a local. So for each iteration, it first does that and then uses that over here. And in this one, I just said, well, we're trying to compare it. Let's just go through the process. We'll not find a match, which is fine. But we've gone through the whole process of producing this with a for each rather than a LINQ statement. Actually, there's no for. The for will be faster than a for each. So anyway, let's look at these two first. They get without LINQ, and then the get without LINQ no to upper, right? So the get without LINQ is here, and the get without LINQ to upper. So basically, the to upper also has a cost, if you will, right? Without LINQ is fine. It's still the fastest so far than any of the previous ones. But the cost of to upper, I was trying to get the cost of the to upper. So if you're doing it without LINQ, great, it's faster. How much of that cost is the uppercasing of the string itself, right? So I just said, I'm just going to do a compare without trying to do the upper to see, and that's of course faster. So the difference here would be the sort of the cost of the to upper. And you can see in memory allocations, there is this one that has the least amount of memory. And then this one has the most amount of memory, even though it's not doing the to upper here. So there's something else going on between these two. I've not dug into it, but it's quite a bit faster than this. I don't have a for statement. I'm saying the for should be faster than the for eaches. So I'm going to quickly write that code. And then we just compare, let's say, the last two, the current fastest version with the for each to see like where does the for compare with that one, all right? So let me write the code. Probably make this, I can just copy this for the most part. All right, so now, okay, I'm now just do the benchmark for these two, only these two methods here. So I'll just comment out all of these methods so we don't end up doing the benchmark for them again. I need the global setup, but I don't need that. Okay, let's do the benchmark. So of course I'll forward this benchmark, or maybe I can talk about something. So what I wanted you to understand is the progression with which this moved on forward, and how do you kind of get to the end result of this? I could very easily just say, oh, I knew all the stuff was going to happen and here it is. But I thought the fun of it was the process, the shock that you get, or the confusion that you have when you see some of the results saying like, I don't understand this. Why is this thing becoming slower? Or why is this thing becoming faster? And so, but the sequence was, I created that baseline with the simplest implementation that I know, which is using a for loop. And I said, okay, well, if it's a for loop can be so much faster, how can I get closer to that for loop's performance, keeping in line with LINQ? Right? That was the original intent. But that's not to say that you should do that, but that's how I look at baseline. It's the simplest possible solution that's easily understandable without using patterns, without using libraries, whatever else that you might think of. Keep it simple. All right, so here we have the net result. We have the for loop that is far slower. Look at that. All right, that does not make sense. What are you looking at me for? I have no clue. Okay, so there's a mistake here, I think. Let me check these two methods out. Okay. You know what I think it is? I think, let's look at the IL. I need to check the IL for this. I think the for each at compile time is getting converted to a for loop because it sees an array. This is the magic of C# lowering, right? It's a beauty of a thing. But it's one more level of interaction, one more layer of magic that you need to understand as a C# developer. What you see is not what it is. Right? So you have to understand where to look or like reason about it. Let's see if my hypothesis is correct here. Need to refresh this or reload. All right, then I want to look at LINQ. Okay, so this is the two upper. Oh, that's a for each. I need to look at the IL here. All right. Yeah, this is a for loop, right? There's no try finally. If this was a for each, there would be a try finally. So even though it's bringing it back like this to be a for each in the C# version, it's not. Would it be any different? No. The IL is not showing me a for each loop. There's no get enumerator and the what do you call it? The try catch, try finally here. Yeah, there's no get enumerator. So that's exactly what's happened. Both of them have, because of the fact that one is an array, the collection is an array, both the for each and the for are identical in that sense. They've just translated to the same code base. Let's look at that. Yeah, it's got a little bit of stuff on the top here, but they're exactly the same in that sense. This is a for each. This is just a for loop. This is not a for each. So what I need, I'm going to change this, the for each to actually rely on a enumerable. So let me go define a variable up top here that is of type enumerable of customer. And let's call it customers enumerable. Right? And we need to initialize this in our thing here. So we'll say var. Can I just assign that to that? I can try that. I don't know. Yes, it should, because yeah, so it'll treat it as this variable. It'll be treated. Did I make it static or something? Oh, then close this out. Okay. I need to change it. Why would it change it? So now I also need to change this. Instead of using customers, I should be using customer enumerable. Right? So that's that. And this is continuing to use that. Okay. So now if you were to look at the IL, you need to just rebuild that and then look at, reload this and look at the code. Okay, see that? That's the try finally. So this is now a for each implementation using the get enumerator method here, as you can see. Where's it gone? There, get enumerator, right at the tail end of this line. All right, so now let's compare the benchmark again. I'll forward this on and I'll fast forward this so you can see the result when I'm done. So now you can see that this is the for loop, is faster than the for each. What was the timing of this first one here? That was 190. So the for each in this case is, yeah, I'm going to get to the bottom of that. Because these are done on different machines also, so I can't really compare it like that. So all I'm comparing is these two here. So this was the original, which is showing up as 190 there. Okay, that was done with an array on top of that. And this is the for loop. So yeah, so the for is faster than the for each, provided of course you're not working with an array in both cases. And of course, in order to use a for, you need a list, which is also an array under the hood. In case you didn't know that, in C#, all lists of T's are actually implemented as an array. And behind the scenes, of course, it grows the array when needed by reallocating and copying all the data over from the one place to the other place. All right. So now we know that there's one more missing is the for each one. And this is the kind of the outcome of the LINQ statement. Let's just examine the for statement here. So this is the fastest implementation. And of course, I could have made it so that it actually matches the items here. But that's the fastest implementation. So that was my baseline when I first started. I said, okay, let me just get to a 4 and see what happens. Like how much is, as compared to these two. And then I went back and started to improve on the LINQ statement by using the let LINQ statement, which totally massacred the performance. And then I sent out the problem, if you will, the quiz to my colleagues, and they came back to me with their own versions of what they thought would be faster and tried that. So basically the fastest was the baseline. The simplest solution is the fastest. Now you could say that clutter you probably don't want to see in that one method. Okay, then extract it to another method, right? It's just call it from that method. So the call side just sees one method call, says, get me this set of people that are in any one of those lists, and there you have it. The implementation is not really that critical. And so my recommendation going back to the beginning was use LINQ wisely. If performance is not such a critical thing in that part of the application, use LINQ, but keep it simple. Keep the LINQ statements simple, because you start using let and stuff like that, you don't know what the heck is. There's no reason to waste resources, right? CPU, memory, time, all of that. So keep it simple. I think just sticking to a where is just fine. Because I've got many other problems of beasts with LINQ. Like the to list, you make it so simple and it's all this allocation. It's just not something that I recommend. In performance critical parts of the application, or if you're building a library that's supposed to be intended to be performance critical or is performance critical, don't bother with LINQ at all anywhere. Just stick to the for loop or the for each maybe. Right? So these are the much better options than a LINQ statement. Even though LINQ statement might seem simpler, succinct, beautiful, it's not the right way to go for that scenario. All right. So this brings us to the end of this video. I hope you've enjoyed yourselves. I hope you learned a few things. If you have, please give me a thumbs up, and I will see you next time.